Hello everyone and welcome to the video on inverse functions. I know that we have just completed exams, so I'm assuming that at this point that you are looking at this video after you finished your exams. So I hope they all went well and that you're ready to work on finishing up chapter 5, get back to chapter 5 in this book, and look at finishing up the material for the AP exam. And also be ready to start and are ready to start preparing for that exam, which will be in the beginning of May. So our objectives for this video are verify that one function is the inverse of another function. You should be able to do that. You should be able to determine whether a function has an inverse function. And the third thing is find the derivative of an inverse function. Now that is going to be the key. A few years ago, this particular section was really the focus. It was a focus on the AP exam to the point where it was something that had not appeared very often, and all of a sudden it appeared, and there were a lot of people that were surprised. It was in the curriculum, but we hadn't seen it for very much, and so they want every now and then AP will do that to go and point out areas, make sure everybody's covering every section that needs to be covered. And so this is that section, the most recent section that was like that. So why don't we get going on this? The other thing on this one is to start out with, a lot of what we do right now in the beginning here, I'm going to kind of speed through it. And the main reason I'm going to speed through it is because this is the stuff that we did last year when we were working with inverse functions back in probably around September or October of last year. Let's start out with a definition here. This is the definition that we dealt with last year. A function g is the inverse function of a function f when f of g of x, in other words, when I put g of x into function f, it will simplify to be x for each x in the domain of g. And g of f of x equals x for each x in the domain of f. Notation-wise, if g is the inverse function of f, we use this notation right there, f raised to the -1 power of f of x. Again, remember, we talked about this last year in a lot of times when we were dealing with notation, function notation, that -1 as an exponent, the exponent look does tend to cause some problems, but this is the inverse function of f. It is not the reciprocal. In other words, let me put it here, f inverse of x is not equal to 1 over f of x. That is not necessarily the case, okay? Is it possible that that could be true? Yes, it is, but for our, in general, it is not, so please do not interpret that notation in that way. Some things that I want you to recall about inverse functions. The first thing is if g is the inverse of f, then f is also the inverse of g. Okay, it's not, you can't, if one function is the inverse of another, then, that it will work in the other direction as well. The other thing that you have on this one, you got to keep this in mind, the domain of f is the same as the range of f inverse, and the range of f is the domain of f inverse. If you remember, when we found an inverse function, we're going to be talking about that in this in a second too, but when we found an inverse function, we did switch the x and y. And the minute we switch the x and y, domain is a set of all x's for a function, range is a set of all y's, so that when we switch the x and y, the domain and the range also switch. If f inverse exists, then it is unique. Okay, a function is not going to have multiple inverse functions. It will have, if it has an inverse function, if it does, it's not guaranteed it does, but if it does, it is unique. Okay, there is one and only one inverse function if it exists for a given f. Graphically, f and f inverses are going to be reflections over the line y equals x. This is a consequence of the fact that we switched the x and y's, okay? If AB is on f of x, then the point BA is on f inverse. Again, we're switching the x and y's. And because of that, the domain and range switch, and it's also that reflection over y equals x. And then a function has an inverse function if and only if it is 1-to-1. The other term that we have for that is strictly monotonic. And what that means, for in both cases, a function is 1-to-1. If it's a continuous function that's 1-to-1, it's going to always be always increasing or always decreasing, okay? Strictly monotonic, that's what that means. It's always increasing or always decreasing, okay? And also, if you remember, we had a graphical test for this. It was called the horizontal line test, okay? A function's the inverse of a function is itself a function if the original graph passes that horizontal line test. It will only be touched by any horizontal line at most one time. Now we get to finding an inverse, okay? I hope, again, that all that stuff, all we've done so far, and even this, you should be looking at that saying, oh yes, I remember doing this last year, or I remember talking about it last year, or I remember kind of doing it last year. You should be, this should be pretty familiar to you. To find an inverse of a function, the first thing we have to do is determine if the function is 1-to-1, if it's strictly monotonic, always increasing, always decreasing. We want to have that. Number two, we're going to solve the equation for x. Now, if this is, there were two different ways that people will go with finding an inverse, okay? This is a little bit different than what we did last year. I'm going to follow what the book has, and I'll show you what that means with what we did last year. I'll compare it to what we did last year as well. Number three, we interchange x and y. Once we've solved the equation for x, we now interchange x and y. Then the fourth thing, we want to define the domain of f inverse, and that's going to be defined as the range of f. And then the last thing we want to do is we just want to verify that they are inverses. Do the composition of one into the other and show that you do get x. Let's look at this example. We want to find the inverse of f of x, where f of x is equal to x to the 2/3 power plus 1, and x is going to be greater than or equal to 0. Now, why do we have that inequality there? That inequality, if you remember from last year, we talked about it then. The purpose for that inequality is to guarantee 1-to-1. If you graph this out, you're going to see a parabolic shape, okay? And so in order to go through and make sure it's 1-to-1, we go and break it at a certain point, and in this case, we're breaking it at the point x equals 0. Okay, so and that will make it 1-to-1. You should pause the video right now, graph this out to confirm that you see that will make it 1-to-1. Also, though, when you look at that, you're going to notice that the domain of f, that's been given to us. X is greater than or equal to 0. The range of the function is going to be y greater than or equal to 1. Okay, that will be the range that we're going to get with this. So pause the video, verify both of these using your calculator. Okay, now that you've verified that when we break this, when we have it set for the domain is x greater than or equal to 0, that the function is 1-to-1, now we can go ahead and find the inverse. Now, you're going to see these two columns here, this one and this one. We're going to focus over here first. This is what the book asks us to do. The first thing we're going to do is now we verify it's 1-to-1. We're going to solve this equation here for x. So we're going to get x equals. So I subtract 1 from both sides. And then I want to go through and get the x by itself. I need to get rid of the exponent. So what I'm going to do is I'm going to raise both sides to the 3/2 power. So I'll get y minus 1 to the 3/2 is equal to x. At this point, we switch the x and y. So I get x minus 1 to the 3/2 power equals y. And this is now the inverse. F inverse of x is x minus 1 to the 3/2 power. And because we know that the domain of our inverse is equal to the range of the original, My range is y is greater than or equal to 1. Well, remember I switched the x and y, so now I have that inequality has become x is greater than or equal to 1. So this right here will be the domain of F inverse. What we did last year, it really comes down to when do you do the interchange the x and y. I know most of you, when you found inverses, what you did is you had y equals x to the 2/3 plus 1, then you switched the x and y. So at this point, you have x equals y to the 2/3 power plus 1. And now we go about solving for y. Okay, so I subtract 1, so I get x minus 1 equals y to the 2/3 power. And again, I want to solve it for y, so I need to get rid of the 2/3 power. To do that, I'm going to raise both sides to the 3/2 power. So I get x minus 1 to the 3/2 power equals y. So in this case, F inverse of x equals x minus 1 to the 3/2 power. And again, x is going to be greater than or equal to 1. Now at this point, you might be saying, well, which one do I use? You can use either one, whichever one you're most comfortable with. Like I said, most of the people that you've had here at Fenton High School have done inverses in this way. From what I've seen from students who have helped during SRT and other classes, as well as from my conversations with you guys as we work through the inverse in pre-calc. This is the one that's most familiar to people, okay? This right here is the exact same thing. It really is up to you. If you sit there and you feel like, oh, I want to use this one, then go ahead. It is not going to make a difference. As long as you follow the process through, you're going to find the inverse function correctly. Now, the last thing we want to do is verify that they are inverses. So what I need to do is I need to find the composition of F and F inverse. So the first thing I'm going to find is I'm going to find F of F inverse of x, which that means I'm putting the x minus 1 to the 3/2 power in for the variable. So I'm going to have, when I do this, I'm going to have x minus 1 to the 3/2 power raised to the 2/3 power plus 1. Well, when I go through on this one, power to a power, I multiply the exponents. When I take 3 over 2 times 2 over 3, that is going to give me 1. And so I'm going to get x minus 1 plus 1, and that gives me x. So the first part of the verification is done. I know that F of F inverse of x does give me x. I now need to go and do the verification for the other direction. In other words, I want to show that F inverse of f of x is also going to equal 1. So what I'd like you to do right now is I would like you to pause the video and go through this verification. So you're going to put function f in for the variable in F inverse and show me that that does simplify to be just x. So pause the video. Once you're done, come back. Welcome back. When we did this one, F inverse, it should have worked out for you. I hope it did. F inverse of f of x. What's going to happen is I'm putting x to the 2/3 plus 1 in for that variable. So I'm going to have x to the 2/3 plus 1 minus the 1 that we have there, raised to the 3/2 power. Well, the 1s will drop off. They cancel each other out. So I get x to the 2/3 raised to the 3/2 power. 2/3 times 3/2 gives me 1, so it gives me 6 over 6, which is 1. And so I get that this is equal to x. And so therefore, I know that these two functions are inverses of each other. Now let's take a look at the derivative of an inverse function. We're going to look at this theorem here. Let f be a function that is differentiable on an interval I. If f has an inverse function g, then I know g is going to be a differentiable at every x for which f prime of g of x does not equal 0. Moreover, g prime of x is going to be 1 over f prime of g of x. In other words, okay, remember these are inverse functions. So What this says is that the slope of the inverse is going to be the reciprocal of the corresponding point on the original. If AB is on f of x, then its corresponding point BA is on f inverse of x. So these are the corresponding points. Make that an A. That AB and BA. So I know the slope of the graph at when x equals a of f of x is going to be the reciprocal of the slope of the inverse function of x at b. Okay, I know that the slope of f of x at x equals a is the reciprocal of the slope of f inverse of x at x equals b. At this point, I want you to pause the video for a little bit and let this sink in, okay? What this is saying and how that works, because we're going to be using that in to help us find the derivatives of inverse functions moving forward. All right, let's take a look at an example. What we're going to have here is we have f of x is x cubed plus 2x minus 1. And I want to go and they want us to find the derivative of f inverse of x at x equals 2. So we're asked to find f inverse prime of 2. Well, remember what that means. That means that there is some value for x I can put in a function f that's going to make this thing equal 2. So to start out with, I'm going to set x cubed plus 2x minus 1 equal to 2. And looking at that, you'll notice that this is going to be true when x equals 1. And so therefore, I know f of 1 equals 2. And so that's going to help me identify the slope of that inverse. Now remember, the slope of the inverse at a value is the reciprocal of the slope of the original at the x value. So in this case, when I'm looking at this point, I have the point 1, 2. The slope of the inverse at x equals 2 is going to be the reciprocal of the slope of the original function at x equals 1. So to find f inverse prime of 2, I know from what we had before, f inverse prime of 2 is going to be 1 over f prime of f inverse of 2, which really is 1 over f prime of 1. And so f of x equals x cubed plus 2x minus 1. F prime of x is going to be 3x squared plus 2. F prime of 1 is going to be 3 plus 2, which equals 5. So therefore, I know that f inverse prime of 2 is the reciprocal of f prime of 1, so therefore it will equal 1/5. This now concludes the video on Chapter 5, Section 3 on inverse functions. We'll do some work with this in class for the assignment, which you see in the schedule that you've already found on Edmodo. And with that, again, I hope your exams went well and that we're all set to move forward and to reach the home stretch, if you will. Basically, we should be done with the material. My goal is to be done with the AP Calculus curriculum before spring break, which means that we finish it up during the third marking period. So we're in the home stretch. You've worked hard so far. It's going to be a little bit harder, and it's going to take a little bit more, but I know you can all do it, and we'll see you in our next class.